Hello there. My name is Adam Dewberry. I'm a consultant data engineer at InfinityWorks. So I design and implement cloud data platforms and help companies through digital transformation. I've worked on projects ranging from the electric vehicle industry, online gaming, to wine buying. Each project required a data platform, which was used to drive insights such as seasonal trends, sales metrics, and even does the product work? I'd like to share with you the lessons learned through building data platforms, from on-premise servers, migration to the cloud, to shiny new greenfield cloud solutions. This is my take on what can really make or break a data project. We will explore first-hand accounts of how people, technology, and processes are the cornerstones to building out your data capabilities. I want to save you the trouble and help you get the best out of your data. Architect systems and processes that will make a platform designer weep. A common trope in development is it's not the tech, it's the people. But sometimes it's both, and more so in the data space. Data engineering as a discipline is quite far behind software engineering. It is rare to see version code, automated deployments, using multiple environments, and even lacks testing. Data cleaning and processing is often handled by the analysts, and it's run on their machine. They have directories of scripts that they own and email around to each other as analysis v1, analysis v2, v2 final, v2 final final, and so on. I'm sure you've all seen this. Or better yet, hand it off to a sysadmin or a platform engineer to run and automate it. A typical path into data engineering is through data analysis. A company says, we have data, we have analysts, give me reports. Through not understanding the role and how to get there, they're expecting the world. In reality, between the data producers and consumers, they need a crack squad of data engineers, but organizations often don't realize this. To them, it's pushing shapes into a mold and outcome graphs. The scope and complexity is unknown to them. If this is sounding familiar, or perhaps you're at the beginning of your data journey, it's worth asking, what is a data engineer? So from a quick online search, the first definition that came up was, data engineers are responsible for finding trends in datasets and developing algorithms to help make raw data more useful to the enterprise. I'll stick that up on screen now. I'm not sure if I quite agree with this definition. Personally, I would leave it to the analysts and the data scientists to find the trends and develop the algorithms. How about, what does a data engineer need to be good at? Creating reliable pipelines, combining data sources, architecting data stores, architecting distributed systems, collaborating with data science teams, and building the right solutions for them. I think we're onto something. These are all essential skills, but even at 5 points, that's a lot to cover. How about roles? 3 common roles are a generalist, pipeline-centric, and database-centric. There's definitely some truth to this. Some are more technology-led, and others are business-led. For instance, the pipeline may not care what the data is. It just pushes it where it needs to go. The database will likely need to know what the data is to map it based on how it relates to the business. We hear the phrase unlocking the value in your data. We have all of this raw stuff, but how do you get to the value? Based on tasks and roles and getting to the value, I believe the following is a good stab at a definition of what is a data engineer. So a data engineer is someone who's responsible for setting up the systems and pipelines which capture, store, and process data in a meaningful way and give access for others to derive insights from and support product functionality. I've worked with a number of businesses who didn't understand this landscape and what this translates to as part of their offering. So to put it bluntly, stakeholders and management sometimes infant understanding can make and break your project and the team's enthusiasm. This was my experience in my first position. I was hired as a data analyst. I wound up doing more than I'd bargained for. I worked with a relational database, a SQL Server instance, and a NoSQL JSON store, AWS's DynamoDB. And my employer said, here's the data. I want daily reports. I knew how to do the analysis. It was simple stuff. But getting data out of DynamoDB and turning it into something useful each day was a new challenge. I wrote some Python scripts to grab the data, munge it, plot, and produce PDFs of the outputs, which automatically emailed to the stakeholders. It was slow going, developed against production data, and to get new features out, I did a git pull on the server, whirring away in the cupboard next to me that run the scripts. Each day, the data grew in size, and it took longer and longer to run. Another.
Adam,
Hello.
excuse me, we cannot see your slides. I'm not sure if you started sharing them, but we cannot see them.
Oh, my mistake. Yes, of course. Thank you.
Okay, sorry for technical issues and interrupting.
Oh, my apologies, everyone. It's all in the words anyway, but yes, let's continue. So where had we got to? It's taking longer and longer to run. So another issue, yes, is as the sole analyst, I had to service all the data requests, and we were pretty under-resourced. So I had become the bottleneck. We couldn't get things out fast enough. In a performance review, my manager said the higher-ups weren't happy and I was moving too slowly. So this hit me pretty hard. I was giving everything I had and doing two jobs. I was in the center of the Venn diagram for data analysts and engineers. I was responsible for the, albeit primitive, systems to capture data, pipelines to transform it, and the analysis. And this became my first big people lesson. It's important your colleagues and the company as a whole understands your role and what you do. So the second lesson came swiftly after. Give visibility to what you're doing. Don't silo yourself away and pop up now and again with results. Keep the conversations open and set realistic expectations and don't overpromise. So my apologies for not sharing those slides. So I'll just take you back quickly to what that diagram looks like. So JSON store on the left, we have a very old piece of tin in the middle, our relational data warehouse, and then Excel and dashboards and so on. Okay, so how can we do better at this? There must be a way. How can we get to this raw data and get it into reports? How can we do better and move faster? Evidently on paper, I was the issue, or at least what I represented in being the bottleneck was. I needed people power without the ability to hire new team members. How could we use the existing skills in the company so people could self-serve? There was a number of data consumers who knew SQL. What if I could flatten and store the data in a relational database and refresh it daily? The middle of our new diagram. I put forward a simple design to modify the existing scripts in ETL jobs, build a data warehouse, and give access so that people can fish for themselves. This should take the burden off me, widen the bottleneck, and keep the stakeholders happy. We started to get somewhere. We were on the way to building a data platform, extracting source data, transforming it, loading it. We had a relational data warehouse, which people can query. We can plug in dashboards and to automate drag and drop analytics. I felt like we'd put down the rocks and carved out stone tablets. Having automated the process on the company server, we were in the age of tin. So through creating a self-service platform, people were able to run proof of concepts, check stats quickly, and build out new reporting independently. The first iteration was complete, and we were finally winning. So I'm sure many of you agree, migrating to the cloud is a common path in digital transformation. Using vendors like GCP, Azure, and AWS can dramatically reduce the overheads of your system, provide round-the-clock support, and feel like they have a near infinite amount of managed services to get your product up and running. In this case, data was our product. Could we move these ETL jobs in the data warehouse to the cloud? Since the product was in AWS, it was time to investigate services like RDS and Lambda to evolve this cloud on-premise hybrid world and ditch the tin. Unfortunately, this all came to an abrupt end, but the journey doesn't end here. It was time to find another position. I decided I need to understand and define my role. It was essential that the company I joined truly understands what that entails. I could foresee if I continued with data analysis, moving to data science, I would encounter this problem time and time again. I would always have to clean, wrangle, and build pipelines to get to the data I needed. You often hear numbers of 70% of a data scientist's job is preparing data. Knowing that feeling, I'd rather go down a path that was well-defined and understood. I was to be a data engineer. So the big learnings during this time is to derive value from your data. A data platform is essential, and people should self-serve analytics and reporting. You and your team shouldn't be a silo or a bottleneck. Roles should be clearly defined and well understood. The stakeholders and management need to understand at a high level what's required. If they don't, you need to teach them and convince them of how to grow your capabilities. A huge component that was missing during this project were good software and platform engineer practices. As mentioned, it was developed against production. There was no dev or testing environments. Code testing was sparse, and I was actively told not to waste time on it. There was some automation, but only for running the code, not deploying it, and certainly not checking for failures. There's nothing worse than someone coming to you and letting you know your systems have failed and the business hasn't got what they needed. Perhaps it's some report or something that didn't run. The numbers aren't right. We should be the ones telling others that the processes have stopped. But it's all in hand, and we know the root of the issue. We can fix it. It's on us. We are the ones putting that information forwards. So for my next position, I knew that I needed to understand what runs the code and automate as many processes as possible and build a platform as though I was building software with all the practices, testing, and robust design as possible. If jobs failed, we needed to know. We would need a reliable system that alerts to failures and provides system health checks. I could hear the faint whispers of DevOps. It was time to broaden my T-shaped skills and become a YAML engineer. Previously, any tests were run locally, on my machine, as mentioned. The code was developed against prod, and a Git pull would update the production server's analytics code. Absolute barbarism. I needed to reliably test and deploy my code and ensure it's repeatable. That smells like continuous integration and continuous deployment. Software and platform engineers use tools like Git, have well-tested classes and methods, harness automation through CI/CD, and go as far as infrastructure as code to build their system. Data doesn't tend to do this. I've never once met an analyst who said, all of my projects have tests. I developed against dev and testing data. We use different environments and our ways of working to not only speed up our deployments, but do it in a safe space and to adhere to data governance and not develop using personal identifiable information. I'm sure many of you are now thinking, this is heresy. You test in production? You push to master? Oof, no. But in data, who's to say any differently? Especially if you're a small company with a couple of people. In my next role, I was to be a consultant with InfinityWorks, my current employer. The thing I wished for greatly was a superb teacher. They certainly delivered with Oscar Barlow, and the pair of us were to migrate 8 on-premise SQL Server instances to Snowflake, a cloud data warehouse SaaS offering. From day one, we were using automated testing and deployments with Jenkins. We still had a manual process for promoting code to production, but importantly, used or had automated dev and staging environments so we can sandbox in, develop in. All of our systems were in code. The platform was built in AWS, and we used Terraform to manage and deploy everything. Bar the initial setup and bootstrapping problem, it was 100% as code. All of our resources in Python were versioned and truly tasty. By the nature of migration, we had to set up the Snowflake database to receive the data, to recreate the mappings of the data model. Data modeling. This is a new component, turning data into meaningful information, to relationally map it back to the business and product as a table and views so analysts can get at the data and bring some value from it. Relational databases are typically built by running a lot of SQL commands. Create table, create schema, etc. Is this where our beautiful engineering practices and tooling fall away? How are we to create the role-based access control, the model, and deploy table statements? The answer came in the form of DBT, Data Build Tool by Fishtown Analytics. It's essentially SQL wrapped in Python's Ginger templating language. It maps table dependencies to execute scripts in the right order. You can pass environment variables and use it to incrementally load your data, among other features. This is the closest to an infra as code tool as we were going to get. For table creation statements and data loading, it did the job well. I'd highly recommend it. But for the Snowflake infrastructure and role-based access control, it was okay. It felt like using shell scripts, which couldn't automatically do a diff to handle change control. We had to explicitly write auto statements and then change it back afterwards. It was versioned and tested, but not fully automated, and was very procedural. I brought with me all of the learnings from the previous job, and with a good senior, we delivered a solid platform in only a few months. People weren't the issue. The process was fairly simple, and it was choosing the right tech and implementation that became the biggest challenge. That's a win. If you can design and develop unhindered, you'll have a fun time. The only niggle I had was how to effectively build Snowflake through code. Between this project and the next, I had a few weeks on the bench. I wanted to solve this issue, or like most developers, search Stack Overflow on the web to see if someone else had figured it out. Turns out the answer is yes. The Chan Zuckerberg initiative had published an open source Terraform provider. It was still fairly young, but had enough resources to build out a data warehouse and RBAC model. I played, tinkered, and presented it back to a group of engineers within InfinityWorks. At the time, we have the answers to deploy Snowflake 100% infrastructure as code, which can intelligently figure out all the change statements. We don't have to stick with those alters anymore. It's just one piece of configuration. Terraform has wonderful features, such as modules. Think of modules like writing a method, bundling up useful code in a repeatable way, which when you pass some arguments or environment variables, will consistently produce reliable infrastructure. We built automated pipelines, which move data from AWS S3 storage to Snowflake. These are dependent on around 10 resources with cyclic dependencies. We'd wrapped these up into nested modules, which with 2 inputs, the S3 bucket name and key, could dynamically create all of the infrastructure and roles needed to set up event-driven ingestion through CI/CD in about 30 seconds. We could decouple infrastructure, isolate components, preventing a tangled mess of resources and dependencies. This was a significant win for us. We could spin up new ingestion pipelines in minutes through a PR process. No need to custom build each pipeline. We had reusable patterns and automated deployments. Next, we worked with a data modeler to pick apart the data and stitch it back together based on the business definitions. We started building out the data warehouse for analysts to access. We had governance processes, automatically masked sensitive information and PII data. And with Terraform building the system side of Snowflake and dbt at the helm for the data model, GitHub Actions supplied the CI/CD power, and we had a fully operational battle station. So let's pause and look back at the data engineering skills list. Creating reliable pipelines, combining data sources, architecting data stores, architecting distributed systems, and collaborating with data science teams and building the right solutions for them. We are certainly ticking these things off. We've got robust systems, monitoring, alerting on the pipelines. We consume product and external third-party data and funnel them all into a data warehouse, which is prepped and ready for analysts to chew on. We did performance optimization for presenting the data to consumers. If you're interested, look up Lambda data architecture. We solidified our processes and made as much of the system reusable as possible. We're on course for building a world-class system, one that any software or platform engineer would admire and want to work on. At each stage, we were moving and pushing the problem to the right-hand side. The journey started with doing a Git pull to get some Python onto a server. Now we use software engineering practices, DevOps, GitOps, the lot, to write reliable code and have those platform DevOps practices to automate getting it into production, ensuring stability and reliability. We even bridged the gap to the data model and continue this 100% infrastructure as code crusade. But now we're on the boundary to analysts. Has the wave crested and we stop here? We've pushed our role and ways of working to the max, but is the chink in our armor now the analysts? We can't let this train end. We need more. We need to help the analysts. It's the day when someone comes to you and says, I need to update this table that Jeff made. Do you know how they did it? Or what the table statement was? Absolutely not. If Jeff used their own bespoke staging tables, we can't necessarily recover that, at least not trivially. But do you know what can? Git. Have you heard of dbt? No? Well, how about we run a training workshop on these things? And that's how it began. We put together an introduction to Git and GitHub workshops to share the skills. The analysts started to think like engineers. They could build their own projects and repositories and then contribute to ours. We helped improve their development flow and access to the code base, empowered them to contribute their own changes to the data model, extend pipelines from simple reusable patterns without even having to know the language. They could self-serve data infrastructure, let alone self-serving reporting. You have to appreciate, it's really hard to hire good data engineers with a broad skill set. They're like gold dust. We had 60 product engineers on our left, 4 data engineers in the middle, and 20 analysts on the right. We were again the bottleneck to the business's ambitions, just with a grander scale. They understood the importance of data engineers and the processes, they were great, but they just couldn't hire fast enough. We couldn't build and service requests to the speed of their desires, and also delivering a solid platform. If you have too many bespoke requests that are just bogging you down, you need to figure out a way around this. So how can we turn analysts into engineers? I'm sure many of you have heard of or worked in cross-functional teams. This is essentially what we're trying to extend to the analysts. We encouraged them to pair with us to create what they needed. This grew into a series of workshops to teach all product engineers and analysts about our system, how to use the tools and build their own components and pipelines. We are migrating the effort back to them. Why would they want to wait 2 weeks for their ticket to enter our sprint when they could just do it in a half day themselves? This leads me to the next big lesson. Don't just create self-service analytics, provide self-service data pipelines and infrastructure too. If you've made yourself redundant to business as usual requests and repetitive requests, you're doing well. One thing we haven't talked about is data quality. Beware the chaos of producers sending whatever they want your way without data standards in practice. You may find, especially in the unstructured world of JSON, that squads and teams often develop their products in a silo without an agreed data standard. Trying to clear this up later or handle changes in the data structures later to include the new and previous versions is a nightmare. It's too big of an ask. Work with the teams and the tech leads to agree common unstructured formats, which include standardized field names and version numbers. You could give them the flexibility of within this key, you can have whatever nested values you would like, but at least in the top level, have that standard. So you have some flexibility in that body. You'll be able to push it through the kind of same molds and pipelines, but you should have those common fields to identify where things have come from, where things should go. Assign data owners early. Agree who is responsible and accountable for the reliability and cleanliness of what is produced. It doesn't have to be the same person, and the roles can be shared. To test the quality, build in validation steps. Actively fail data that shouldn't make its way to reports and break downstream processes. Talk with the data owner, find out what's going on and fix it together. So before we sum up, there's some final points that I'd like to leave you with. Data engineers will always play catch up to the product and are often an afterthought. The system is due to go live on 1st. When do we need reports? There's no requirements. So we just continue the backlog. We reach launch day. Where are the reports? We need daily and month end. I've seen this time and time again. Thankfully, you can anticipate this. Start conversations early and work with other squads proactively. Seek out how you can interface with the product and the downstream analytics to support new builds. Always remember, people focus on product development, especially when launching a company. To them, data isn't really a first-class citizen. It's more of an afterthought. Relieve yourself of future pressures and build alongside the product. Design the two together. Each should have a roadmap. One possible way to mitigate this is to federate out your squad to individual project tribes. So you can send your data engineers to other groups. They would attend the roadmap sessions to learn what's required and understand the timelines and build alongside them. You can then anticipate what's data and things you'll need to receive, the structures and services that you need to build. So we've seen success with this with one of our customers. Well, the one that I'm working with. So each squaddy has their own domain, and we often complete the production data systems before the production engineers have actually released theirs, because we've understood what's required. We know what's going to come, so we can put it all in place and it's ready and waiting. And it's just all repeatable patterns. So last year, we began a relationship helping an automotive company launch an online car store where you can buy a car in about 10 minutes. If you just put in a few search parameters of brand, engine size, things like that, you'll be shown pictures of the exact model that you want. Click buy, and within, let's say, 2 or 3 days, it will be delivered to your home. So for this, we'd built reusable pipelines. We had automated all of our deployments and had open information flow with the business owners. From having sign off to use Snowflake, the data warehouse solution, we had a data warehouse and reports within 5 days. So 0 to repeatable, automated analytics within a week was a fantastic achievement. So we've got some good principles and an action plan to take to any project, from ways of working, tech implementation, to fostering good people practices. So what have we actually learned through this? To build a great system, we need to balance people, processes, and tooling. We need to understand effective ways of working, clearly define roles, to help stakeholders understand the problem and how to achieve a solution. Visibility is key, always. Whether it be a sprint burn down or a show and tell, you need to shout about your successes and have the conversation if things aren't going as expected. Work with people, don't be siloed. Requirements change or come at the last minute. You need to pivot and accept the uncertainty. Anticipate data will always be last, but when it's needed, oh boy, it's needed. Work with stakeholders and find out their vision. Make a roadmap alongside the product roadmap. Governance and process is important. Not all data should be democratized. For processes, test and automate as much as you can. Create a platform for people to self-serve. Make yourself redundant to business as usual tickets. Teach people how to access the system and why and how you designed it in the way that you did. For tools, use versioning, something that does diff detection. Automate your deployments with something like Terraform. Pick a CI vendor, whether it be GitHub Actions, Circle CI, Jenkins, any of those. Automate those tests and your deployments. That should be doing the heavy lifting for you and creating those pipelines. If you can, aim for 100% infrastructure as code. You'll thank yourself later. And whenever anyone new joins a project, it's its own self-documentation. Set up monitoring alerting on unexpected behavior. If you're expecting a report to be sent out at 9 a.m. on a Monday morning, have a monitor that checks, did that file go? Did something land? Not just is the data correct, but are the processes working? Document your environment setup. Sometimes these things can become very messy. So have clear documentation throughout. So any new people that join can understand. You have your risk logs, your decision logs, all of these kind of things. All of those wonderful software principles and ways of working, bring into your data teams. So remember, data is an infant in the eyes of software and platform engineers. Give them a break and teach them how to be better. That's all from me, folks. Thank you. Do we have any questions or a Q&A? Nothing as of yet. Well, it looks like we can end it there. So thank you for coming.